Hello, and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 15. So the directions for 15 say, find all missing sides and angles for the right triangles below. For 15b, round answers to the nearest tenth. So the implication there is that for 15a, our answers should be exact. So let's go ahead and take a look. So 15a, find all missing sides and angles. So for this particular triangle, we are given two of our sides. We're given AB and we're given BC. We're given one of our angles, which is angle C, which means we're missing one side, AC, and we're missing two angles, A and B. So there are a couple different ways to answer this specific question. If I had to sort of identify like what is the ideal way of answering this question, the ideal way of answering this question is to recognize that this is a special right triangle. So if I kind of redraw it for a second over here. All right. So in order to recognize that this is a special right triangle, notice that, if the picture is drawn to scale, we have a short leg and we have a long leg. And notice that in this picture, we're given the hypotenuse, all right? And then we're given the short leg, which has been labeled as 6. Now, I'm not going to label as opposite or adjacent because I can only do that if I'm talking about a specific angle, and I haven't really identified an angle that we're talking about here. But I can label the hypotenuse. Notice that in this picture, if I let the short leg equal x, then I can express my hypotenuse rather as double that, right? So notice that my short leg is 6, and notice the hypotenuse is 6 times 2, which is 12. So I have something that looks like this. This is a 30, 60, 90 triangle. It is one of two special right triangles that you should have seen at this point. The other one being a 45, 45, 90 triangle, which is also an isosceles right triangle. So if you can recognize that this is a special right triangle, if you can recognize that this is a 30, 60, 90 triangle, this question becomes fairly straightforward. Because in a 30, 60, 90 triangle, not only does the short leg and the hypotenuse have this sort of relationship, but you can also connect things to the long leg, okay, which is the side that we're missing. In a 30, 60, 90 triangle, if your short leg is x, then your long leg is x root 3. All right. So if I go back to my original picture here, my short leg is my short leg is 6, which is like in the place of x. So then AC, the long leg, is going to be 6 root 3. I'll even say that right here. Say AC is 6 root 3. Okay. Now we're missing our angles. Well, the whole reason why it's called a 30, 60, 90 triangle is because the interior angles are 30, 60, and 90. So now, obviously, angle C is the 90, so we just got to figure out, well, A and B are 30 and 60, but we just got to figure out which one's which. Well, note if you look at them, if you look at the picture that we drew, right? The angle at the lower left certainly appears smaller than the angle in the top right. Also, the smallest angle is going to be across from the smallest side, which is x. So that means that the 30 has to go there, and the 60 has to go there. All right, so I'll just add that to this picture here, 30 and 60. All right, so angle A is 30, and angle B is 60. And those are my answers for 15A. Now, If that makes sense to you and you don't want to see a second way of doing this problem, that's fine. You should go on to 15b. However, we'll start over here. If you did not see that this was a special right triangle, a 30, 60, 90 triangle, you can actually still answer this question. Okay, so if for whatever reason, if you kind of struggle to find special right triangles, to see special right triangles, but if you just want sort of a fallback like plan B, that'll work in like lots of different triangles, not just a special right triangle, but lots of different triangles. Like I said, you can also answer this question using some different tools in our toolbox. So we're missing a side here. We're missing AC. So I'm going to go ahead and label that as X. Notice that's a different X than the one that I had before. We're starting this problem from scratch. We're not looking at special right triangles, and I'm just solving for X. If I want to solve for X right now, well, I have a right triangle where I know two sides and I'm missing a third side. And I want the third side. Well, in that situation, you want to use the Pythagorean theorem. The Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. That is commonly written as a squared plus b squared equals c squared. C has to be your hypotenuse, and a and b are your other legs in either order. So it does not matter which one you make a and which one you make b. So I'll just start off with the x that we're looking for. So x squared plus 6 squared equals 12 squared. So therefore, x squared plus 36 equals 144. Subtract 36 from both sides, and you're left with x squared equals 108. All right. Now I want to take the square root of both sides. So we get x equals. Now, if we were just solving some kind of abstract algebraic equation here with no context, I would need to introduce a plus minus, because I don't technically know if that original x was positive or negative, because when you square it, you always get a positive, assuming it's a real number. However, this is not some abstract scenario. We're talking about the side lengths of a triangle, and I know that x is in fact positive. So in this case, I do not need to introduce a plus minus, but just be aware that in the future, if you're just solving an equation and you don't necessarily know that x is positive, you would need to introduce a plus minus here. So what we do need to do is we do need to simplify the square root of 108. So in order to do that, we've done this now in multiple problems in the past. So if you're still kind of getting tripped up by this, I would encourage you to go back and look at some of those earlier videos. But one method of doing this is to start at 108 and go down and check and see what is the largest square number that goes evenly into 108. All right. So if I start at 108 and I go down, the first square number I run into is 100, because 10 squared is 100. However, 100 does not go evenly into 108. If you do 108 divided by 100, you get a decimal. In fact, you get 1.08. Okay, and if you get a decimal, it doesn't work. So let's keep going. The next square number after 100 is 81, because that's 9 squared. 81 does not go into 108. The next square number after that, or below that, is 64, because that's 8 squared. 64 also does not go into 108. The next square number after that is 49, which is 7 squared. That does not go into 108. However, the next square number is 36, which is 6 squared. And that does go into 108. It goes into 108 3 times. All right. So another way to write 108 is just 36 times 3. And if you write it like this, if you write x equals the square root of 36 times 3, then when you take the square root of 36, you get 6. And then the root 3, the 3 has to stay underneath the square root. You can't pull it out from underneath the square root there. All right. And so that means that AC is 6 root 3. So we now have all of our, and obviously knows that this matches our earlier answer from when we recognized that this is in fact a special right triangle. All right. Now, again, suppose that we still have not recognized that this is a 30, 60, 90 triangle, and we have to actually get the 30, we have to actually get the 60. So we're going to have to use trigonometry at least once, and then to get the other angle, you don't have to use trig because we'll know two of the three angles, and so we don't need to use trig to get the third one. But we do need to use trig to get one of the angles. It doesn't really matter which one you get. You can get A or B. I'll just kind of arbitrarily choose A. So if we're going to use trig here to get this angle, we've got to label our triangle opposite, adjacent, and hypotenuse. I recommend that you start with the hypotenuse, which in this case would always be 12, regardless of which angle you're trying to find. And then because I just kind of, quote, randomly chose angle A, I'm going to label the 6 as opposite. I'm going to label the 6 root 3 as adjacent. All right. So now I know all three of my sides now, so I could really use any trig function I want. I suppose if I were to do this problem, I would probably go back and use the original values. So these guys, this guy, and this guy, right? Just on the off chance that I made a mistake with the 6 root 3. I mean, we didn't. The 6 root 3 is correct. But just on the off chance that I did make a mistake, I might as well use the original numbers of the problem to kind of limit the damage of the mistake if I made one, right? So we're going to use opposite and hypotenuse. And so you have to ask yourself, all right, well, so, ka, toa, which trig function, sine, cosine, or tangent, involves opposite and hypotenuse? If you don't know, I encourage you to pause the video and try to figure it out. The trig function that we want to use is we want to use sine. So sine of my angle, which is A, right? Trig functions are always of an angle. So sine of A is 6 over 12. Okay. And I want to get A by itself, right? And right now A is not by itself because it's kind of inside the trig function. To get rid of sine, we want to use the inverse of sine, and the inverse of sine doesn't have a special name. It's just sine inverse, or arcsine. But for right now, we're just going to say sine inverse. So when I do that, on the left-hand side, my sine inverse and my sines cancel, pretty much by definition. So I'm left with just A. Now, I applied sine inverse to the left-hand side, which means I also have to apply it to the right-hand side. So I want sine inverse. Now, you don't have to reduce this fraction, all right? It's 6 over 12. However, if you do reduce it to 1/2, you might notice something. You might notice that essentially what this question is now asking is it's saying, what is the angle that results in a sine measurement of 1/2? Well, we just went over the unit circle. And you may remember that on the unit circle, your y value equals 1/2 when you are at 30 degrees. So you could actually avoid using the calculator on this problem if you sort of recognize that sine inverse of 1/2 is 30 degrees. Now, if you don't recognize that and you need to evaluate this on the calculator, then you need to make sure that your calculator is in degree mode. Okay, so degree mode is, okay. So if you have a TI-84 CE, you'll notice that at the top it gives you a bunch of information here. Notice that right now it says radian, so you need to go into mode and you would need to go down to where it says degree. You need to press enter. Right? And now notice it says degree, so second mode to quit. And now if you type in sine, if you type in sine inverse, so that's second sine of 1/2 or 6/12. If you don't reduce it, you'll still get the same answer. And notice that we do in fact get the 30 degrees. If you had used cosine, you would have used the 6 root 3 over 12. And then if you would use the tangent, that would have been 6 over 6 root 3. just like that. Yeah. So another good reason to use the sign for the opposite and the hypotenuse is you get to avoid having to use the root 3, which just kind of makes it a little bit more difficult to type in. Notice that for tangent, the 6 root 3 would need to be in parentheses itself, otherwise you'd get the wrong answer. So a number of good reasons to use the use sign, which is opposite over hypotenuse. So getting back here to the problem. So okay. So A is in fact 30 degrees. So label that as 30. Now, you could use trigonometry to now get angle B, but I wouldn't recommend it because it's at this point you know 2 of your 3 interior angles, okay? And triangles always sum to 180 degrees. The interior angles of a triangle are always 180 degrees, at least on a flat surface. So to get angle B, you could either take 180 and subtract, 90 plus 30, okay? Or, even better, is you can recognize that, well, in a right triangle, your 2 acute angles are complementary. They sum to 90 because in all 3 of them have to sum to 90. So in a right triangle like this, if you know one of your acute angles, you can just take 90 and subtract the other one, and you'll get 60. So my final answers here, AC is 6 root 3. Angle A is 30 degrees, and angle B is 60 degrees. Probably not a bad idea to just sort of write your answers in a way where, whoever's taking a look at this kind of knows what they are. They don't have to go hunting for them, right? So probably not a bad idea to sort of summarize your angles there. So several different ways of solving that problem. Again, the ideal way is to recognize that it's a special right triangle, and the benefit to you is that it's a lot less work, okay? But again, if you did not recognize that this was a special right triangle, you can still answer this question. You need to use the Pythagorean theorem to get your missing side, and then you need to use trig to get an angle, and then just finish it up to get your final angle. Okay, B. So for B, we again have a right triangle. This time we are given one of our legs, and then we're given one of our acute angles. So in order to finish out this problem, we need to solve for our 2 missing sides and our 1 missing angle. I would recommend that you well, I guess the order doesn't really matter. If I were doing this problem, I would get my missing angle first. Just because it's like the easiest part of the problem. And the reason why it's the easiest part of the problem is that you don't need to use any trigonometry. You can, although I wouldn't recommend it, especially not right now. I guess you would have to find one of your missing sides first, then get the angle. So as I said in part A, as everyone knows, or hopefully everyone knows, the interior angles of a triangle sum to 180 degrees. And in a right triangle, because one of your angles is itself 90 degrees, it means that the other 2 angles have to sum to 90, which means that they are complementary. So if we're looking for angle A, right, the measure of angle A, well, I know that angle A and angle B combined have to be 90 degrees, which means angle A is going to be 90 minus the measure of angle B, which is 24. So I end up getting 66. So this angle right here is 66 degrees. Okay, so in order to finish out this problem, we just need to now find our 2 missing sides. And it doesn't really matter which one we get first. Yeah, it doesn't really matter. It also doesn't matter which angle measurement we use, if we use the 24 or the 66. I guess the algebra is a little bit easier if you use the 66, but if you don't see why that's true, let's go with the 24 anyway, because it can sometimes be hard to see sort of like what's down the line until you get there. So if you don't see why the 66 is going to be a little bit easier to use in this problem, let's go ahead and use the 24, because I would like everyone to be able to handle, what happens when you use the 24. So if you're going to use the 24, so angle B, I recommend circling the angle so it's very clear which angle you're talking about. Now I want to label this triangle opposite, adjacent, and hypotenuse, and I recommend you start with the hypotenuse, okay? So the hypotenuse is always, always, always across from the right angle, right? So it's here. So this is H, okay? So this triangle's kind of like been tilted over, right? But so you can't rely on it being like the slanted side. That doesn't work. You have to find the right angle and then go across from that, and that's your hypotenuse. All right. Now, because I'm talking about angle B, I'm going to label the 3.7 as opposite. It's across from the angle that I'm talking about here. And then the leg that's next to it is adjacent. Okay. So I have to get both adjacent and hypotenuse, and I have to do it in, kind of two different steps. It doesn't really matter which one you get first. I guess I'll go ahead and get the hypotenuse first. So we'll call that X. In this part of the problem, I'm looking for which trig function connects what I know with what I want to know, right? So I've circled opposite and I've circled hypotenuse. So you got to ask yourself, all right, which trig function, sine, cosine, or tangent, connects those two things? And the answer to that question is sine. So based on how I've set up my problem, for this problem, I'm going to end up using sine. So this is the sine of my angle, which is 24, equals opposite, which is 3.7, over hypotenuse, which I've labeled as x. All right, so I want to get x by itself. And not only is x not by itself, it's also in the denominator. So to fix those two things, if you don't see how to do this in one step, I would not rush, right? You want to get the correct answer. You don't want to rush your answers here. So if you want to ultimately get x by itself, the first thing you can do here is you can multiply by x. And what that does is it gets the x out of the denominator, all right, which is progress, right? Because if the thing that you're solving for, you don't want that in the denominator, right? However, it still isn't by itself because I've got sine of 24. So I have to then divide by sine of 24. So I end up getting x equals 3.7 divided by sine of 24 degrees. So now, if I want to evaluate that, just make sure that we do this correctly on the calculator. Again, you want to make sure that you're in degree mode, which I am. So I want to do 3.7 divided by the sine of 24. And it said to round answers to the nearest tenth, so my answer is going to be 9.1. Yeah, well, that's fine. We'll pause there for a second. So what we end up getting is approximately 9.1. And that's my hypotenuse. Okay. Now we're missing one side. And at this point, you've got some options. You could use the Pythagorean theorem here, because you can use the Pythagorean theorem anytime you have a right triangle and you know two sides and you're looking for the third side. The only issue with the Pythagorean theorem is that if you're going to use it, you want to use the exact answer of 3.7 over sine of 24 and not the 9.1. Okay, and that's a little cumbersome, right? Because you don't want to use rounded answers to get additional final answers. Okay, so even though you could use the Pythagorean theorem in this question, I personally would not. I would recommend that you stick with trigonometry. If you do use the Pythagorean theorem, you do need to use the exact value in your calculations, all right? But again, if you do that, and assuming you don't make a mistake, you should get the correct answer. I'm going to use trig, though. So I'm also going to stick with angle B, because I've already labeled my triangle relative to B. If I wanted to switch to the 66, I'd have to swap my opposite and adjacent. I don't feel like doing that. So I'm going to stick with angle B. So I'm going to leave everything the way that it's labeled. And again, I'm going to ask myself, all right, which trig function, and we're going to call this y. So which trig function connects what I know with what I want to know? So which trig function connects opposite and adjacent? And the answer to that question is tangent. So tangent of my angle, which is 24 degrees, equals opposite, which is 3.7, over adjacent, which is y. Well, this is pretty much identical in structure to the first problem, except I've just swapped out tangent for sine. So at the end of the day, if you do the same sort of algebraic manipulation, you should get the same result. I'm not going to do it because it's all the same stuff that you just did. So tangent of 24. So 3.7 divided by tangent of 24. 3.7 divided by tangent of 24. And you end up getting, rounded to the nearest tenth, you get 8.3. So go ahead and indicate that. So this is approximately 8.3. So 8.3 goes there. So just to make life easier on whoever it is that's looking at this, we're going to say that angle A is 66 degrees. We're going to say that AB, which was my hypotenuse, is 9.1. And we're going to say that BC, which was my other leg, is 8.3. And those are my answers. Quick side note here, if you were to use the 66, when you solve for the hypotenuse, you would end up getting cosine. So it'd be 3.7 divided by cosine of 66. Okay, and then if you use the 66 on the other one, you would end up getting 3.7 times the tangent of 66. Yeah. So if you were to use the 66, you'd get the same answers, but you just use some different trig functions. So that is everything for that problem. And so if I zoom out, there are my answers for question number 15.